12B.5 is on systems of equations with quadratics. So if we take a quick look at example 1, we notice that we have a quadratic for one equation and then a line for another equation. And that's what we're going to have. And so we're going to be solving this. And to solve this, our answer is going to look like an XY pair, so a coordinate pair. And we're going to solve by graphing, elimination, and substitution. So first, we're going to start with graphing. So go ahead and write down the directions. Solve by graphing. I have two equations. Note this is a square, so this is squared, so this is a quadratic. And this is in the form mx plus b, so this is a line. Let's make our xy plane. And I'm just going to count 10 in all directions. Let's remember how to graph this quadratic. If we remember our standard form, y equals ax squared plus bx plus c. To find the vertex, we do negative b over 2a, and this finds our x value. And then we plug it in to find our y. So I notice 2x squared plus 1, 2 is my a, 1 is my c. So I have a plus 0x in here. So my b is 0, my a is 2. Negative 0 over 2 times 2 is 0. And then I'm going to plug that in to find my y. Y equals 2 times 0 squared plus 1, and I get 1. This tells me my vertex is 0, 1. Let's go ahead and plot our vertex, 0, 1. Now I'm going to plug in 1, because I notice 1 is 1 to the right. One squared is 1, 2 times 1 is 2, 2 plus 1 is 3. So I have a point at 1, 3. From here, I could have also used the pattern. A is 2, so I go over 1 up 2. That's another option. Let's reflect this over. And for now, I'm going to connect these dots. If I wanted to plug in another point, I can plug in 2. 2 squared is 4. So I'm going to plug in 2. 2 squared is 4. Times 2 is 8, plus 1 is 9. So this gives us the point 2, 9. So this goes opposite, reflect over, and we have our parabola. For the line, I'm going to use y equals mx plus b. My slope is negative 2 over 1. My y-intercept is 5. I plot 5 on the y-axis. And then I go, this is a negative slope, so my graph will look as such. That's a decreasing graph. I'm going to go down 2 over 1, down 2 over 1. And then over here, I'm going to go up 2 over 1, up 2 over 1. Now, my graph crossed at 2 points. We crossed at negative 2, 9. That's one answer. And then at 1, 3. So my answers are -2, 9 and 1, 3. So just kind of to backtrack, I graphed my quadratic. How do we graph our quadratic? We use our standard form method. Found the vertex, plugged in some points, then I reflected, and then I graphed my line. How do we graph our line? Find our slope, find our y-intercept, plot our y-intercept, and count out our slope. So here's our next one. I want you to go ahead and try it. Go ahead and write it down, and then pause the video so that way the students can try this. Okay, so now that you've had time to try this, I'm going to go ahead and do it. A is 1, B is 1, negative B over 2A, -1/2. And then I'm going to plug it in to find my y. Y equals -1/2 squared minus 1/2 plus 3. And when we're doing graphs, it is okay to think in decimals. -1/2 squared is 1/4 minus 1/2 plus 3. So if we want to think in decimals, 0.25 minus 0.5 plus 3 is 2.75. So our vertex, -0.5, 2.75. Let's go ahead and plot that. -0.5, 2.75. And we're just going to have to kind of guesstimate that one, and then we'll see if we need to be more specific later. I'm going to plug in 0 and -1. I plugged in 0 and I got 3, so we have a point at 0, 3. I'm going to plug in -1. -1 squared is 1, minus 1 is 0, plus 3. So I have a point at -1, 3. I'm going to plug in one more. Let's do 1. 1 squared is 1, plus 1 is 2, plus 3 is 5. So that's 1, 5. And then I can reflect that over. Something like that. All right. Y equals -x. So this is in our mx plus b format. We have a plus 0 here, so m is -1 over 1, b is 0. Plot our y-intercept. Negative means I'm decreasing, down 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Notice that our graphs do not cross. No solution. Now we're going to move on to solving by elimination. So go ahead and write this problem down. Now our goal of elimination is to eliminate a variable. So as I'm looking at these, I'm noticing I have to pick. Am I going to eliminate y or x? Well, if I eliminate x, I still have my x squared. So the best strategy would be to eliminate y. So I'm going to stack my equations. I'm going to do the quadratic one first. And then I'm going to do the linear one next. And I'm going to make sure this is a first degree. It's going to line up with, because the power is 1, so it's going to line up with the negative 4x. Negative 7 is a constant, so I'm going to line that up with the negative 5. Am I going to be able to eliminate anything if I add these together? No. So I have to change one of them. I'm going to change the bottom one to negative y equals x plus 7. I just switched all the signs, or you can think about it as I times it by negative 1. And now we can add our equations together. Y minus y is 0. I have x squared minus 3x plus 2. How do I, in one variable, a quadratic, so this means we can factor quadratic formula, complete the square. I always like to check for the first one, can it factor? It can. To get to 2, I need 1 and 2. I make them both negative, that's negative x, minus 2x, that's negative 3x. Now I set both equal to 0, and I get x equals 1, comma 2. Now if we noticed in our graphing, we had an xy pair. So I found my x's. I have 1 and 2, and I need to find my y's. And I find those by plugging them in to one of these two. I'm going to pick this one to plug it into. So y equals negative 1 minus 7, which is negative 8. And then here y equals negative 2 minus 7, which is negative 9. So I have negative 8, negative 9. So again, we multiplied by the negative 1 so that we could eliminate. We factored. I picked the factoring option. Found my x's. Plugged back in to find my y's. You need to write yourself little notes of those steps. Please do. I want you to now try this one. So go ahead and have the students write this down and pause the video so that they can try this. Now that you've had a chance to try it, I'm looking at this. I notice I have y's that I could eliminate, and if I eliminate x's, I'll still have x squared, so that's not smart, so I'm going to eliminate the y. Let's go ahead and stack. I'm going to change my top equation, and I'm going to do that to get my x squared negative. So this gives me negative y equals x squared minus 200x minus 20. Y equals 191x minus 32. The bottom one stayed the same. Remember, our goal is always to get the x squared positive, so I did that by timesing by negative 1, which also made the y negative. Those cross out and become 0. Bring down the x squared. That gives me negative 9x. Negative 52. Again, quadratic. So I'm thinking of factoring. We have a negative 52, so we're going to have 1 plus and 1 minus. Thinking through the pairs, we get 13 and 4. Negative 13x plus 4x gives us negative 9x. Set these both equal to 0. I get x equals negative 4 comma 13. So my answer's going to be like this, but I have to find my y's. I'm going to plug back into the linear equation. 191 times negative 4 minus 32. You get negative 732. Y equals 191 times 13 minus 32. And you get 2,451. So negative 732, 2,451. Our last method is solving by substitution. So the goal is, so go ahead and write down example 5 and then we'll talk about the goal. In order to use substitution, we want one equation to have the variable isolated. So we have y equals, so we have that. And what we're going to do is we know y equals this, so I'm going to take this and plug it in right there. So instead of y here, we're going to write this quadratic. So instead of y, we're writing x squared plus 11x minus 12. And then we're going to write the rest of the equation, minus 30 equals 12x. So again, instead of this y, I wrote this quadratic. This can simplify down. We have an x squared, so we set equal to 0. And we try to factor. I want to get this side to 0. So minus your 12x. X squared minus x minus 42 equals 0. Let's try to factor. I think 6 and 7. Let's see if that's a negative and that's a positive. 6 times negative 7 is 42. Negative 7x, positive 6x, that's negative x. That works. Set them both equal to 0. And I get x equals negative 6 and positive 7. So remember, now we need to find an ordered pair. So our answer is negative 6 comma a y and 7 comma another y. Let's go ahead and find those y's. I'm going to use the linear one to find the y. So y minus 30 equals 12 times negative 6. y minus 30 equals negative 72. Y equals negative 42. We have a negative 42 here. Y minus 30 equals 12 times 7. Y minus 30 equals 84. Y equals 114. We have a 114 here. And that is our answer. So again, we substituted our quadratic into the y, simplified it down, got it set equal to 0, factored, found our x's, plugged our x's in to find our y's. I want you to go ahead and try this last example. Go ahead and pause the video so they can have time to try it. Okay, here I have y equals something. I have my variable isolated. So I'm going to plug negative x squared minus x plus 19 into my y. So I'm going to get x equals, what am I plugging into y? Negative x squared minus x plus 19. And then I have plus 80. Now I notice I have an x squared. So we need to get it set equal to 0. And then I need to simplify. So let's simplify first. Plus 99. I'm going to subtract this x over. I get 0 equals negative x squared minus 2x plus 99. Now, we want x squared positive. So to do that, we're going to flip all the signs. X squared, flip, positive 2x, flip, minus 99. Okay, x squared, factor. Can we factor? 0 equals x. Let's try 11 and 9. Positive 11, negative 9. 11x minus 9x gives 2x. Set them equal to 0. I get negative 11 and positive 9. So let's set up our answer. Negative 11, positive 9. I'm going to plug into this one. And remember, this is my x value, so I'm plugging it into x. Negative 11 equals y plus 80. Subtract the 80 over. Y equals negative 91. Nine equals y plus 80. Subtract the 80 over. Y equals negative 71. And here are our answers. These are the 3 methods to solving. The homework will have you do all methods, so you will have to try all of them. But I'm sure you will find a favorite, but you do have to know how to do all of them.